Hello friends, welcome to this session of Learning R Programming, and in this session we will learn how to plot distributions of data to compare between different categories in that data. And I will bring my data here, set working directory, and that inverted quote I gave there. I will go to the directory where my data is stored, and that is this frworks. I generally store my data in a separate folder, but this time I didn't do that, and will run this code, and this is my working directory now, frworks. I will read the file, and my file which I am going to read I have saved as xlsx file. Therefore, I will use library read excel function, and if you have not installed this read excel, go to tools and install packages, type in read excel there and select from the drop down and click install. Package will get installed. We'll run this line so that functions will be there in memory. Then we will bring that library, bring our data into an object called as df using read excel sx function, and I will just put that inverted quote and bring that file name, that pipetting data 2025. I will click on this, rename, copy that and bring that here. There are many different ways to import data, and this is the one which I am more comfortable with. We'll read that, and path doesn't exist. It's not R file, it is xlsx file. I will run that. Yeah, file got read. Now we will see head of that data, df, and we can see here that it's a table because it has got read by the read xlsx function, and it imports the data as a table object, and table is a advanced or modern data frame, and these columns are there. These are students' name: Bhakti, Sarvesh, Tushar, Shubham, Dhanashri, Shivani. These students have taken these readings. These are the pipette readings. They have pipetted 1 ml volume of water and weighed that volume. And each student has taken 10 readings. I want to compare which student, all the pipetting skill of all these students, and want to find out which students are better at pipetting the solution using glass pipette. This here, using the head function, I got 6 rows and 13 columns. All the dimensions we can see using the dim function, dim, and the dimensions are 10 rows and 13 columns. Each student has taken 10 readings and 13 students have taken the reading. But this type of table is called as wide table, and this is difficult to analyze. Therefore, we need to convert this to a long table. In long table, all the students' name will be there in a column called as student, and these will be values of that column student, and all these measurements, weight measurement, which are there in grams, have 1 unit and are the same measurements. Therefore, those will be there in their own column. Here I will bring the library tidyr to convert this wide table into long table, tidyr, and that df long, I will give it a name to the pivot table or long table. Df will be my argument, data argument for that, and it will be piped into the next function. That next function is pivot longer, and if you see the yellow box here, that is the tooltip text, that tells us that first argument shall be the data, and data argument we are piping in, therefore it's not necessary here. Then second argument is columns, and those calls I will just calls is equal to, and 13 columns are there. I will go for 1 to 13, comma, names of these columns will go to names 2. This is the argument, and these columns will go to column called as students. And next one is values, where values will go to values 2, and these values will go to, I'll just bring that to new line by pressing the enter key before the values 2, and type in there values will go to volume, because this weight actually corresponds to that much volume, because specific density of water is 1 gram per ml, and we as I said earlier, students have weighed the volume they pipetted out just to ensure that they are measuring the correct volume. I will run this and it has got run. We'll see again head of df long. It will also be table because it is output of this pivot longer function, and pivot longer is the tidyverse package function, and therefore for that reason it will provide us the table as output instead of data frame. You can see here it's a table, and because we use the function head, it is showing 6 rows in 2 columns. One column is students, where all those student name will be there and their first readings will be there. Then again those students name will get repeated, and such this set of 10 names will get repeated. Set of 13 names will get repeated 10 times for these 10 different volume readings. And we'll see dim of that 13 students, 10 readings per student. Therefore, those dim will be 130, and 2 columns are there. One column is categorical, other column is numeric. Perfect setting to study distributions or to compare distributions. Now, to plot these distributions, we'll call in library ggplot2, and this is our go-to library because its graph plotting functions are quite intuitive, and layer by layer we go on building the plot. The first function it requires is ggplot, and in ggplot the data name will be df. First argument is data name df long, then the AES, that is aesthetic mapping, x-axis and y-axis we will go for, but first we'll plot monovariate plots, or plots which require only one variable, monovariate distribution plots, and that plot also will have as density plot. Bear with my spellings, density plot, and ggplot is the first function for that. Data coming is, okay, I have wrote the function earlier, df long. AES, volume we want to plot, I'll put volume there. Then this will not give us the plot because we have not specified the geom. We'll specify the geom on next layer, and this plus symbol is very essential, and it shall be at the end of the line. Geom underscore density, and when you see that we have this density curve, but and again it's concentrated or frequency or density of values is more at 1, maximum at 1, and very extreme values are very rare, okay? And most of those values are there in 0.9 to 1.1. Almost symmetrical distribution it is. But we want to compare the students, therefore each student shall get separated out, and therefore we'll map the fill attribute to variable called as the students. I will just copy the name to avoid spelling mistakes, and we will run that. Now you can see that these density plots got overlapped, and those 13 density plots got resolved here. Don't bother about this legend. We can customize the legend also. You can watch my other videos where I have shown how to customize this legend, or I will prepare a new video also just to show you how to customize this legend. Geom density, but this overlap is not proper, therefore we will use there alpha. Alpha is the transparency, and that alpha 1 is perfectly opaque and 0 is perfectly transparent, completely transparent, and alpha 0.3 will make it little transparent, so that overlap will be quite properly visible here. But as you see here, this density plot is not suitable to compare those 13 different groups. We will try histogram also, but I tell you here, for these many groups histogram is also not suitable. Just change this density to histogram. I have copy pasted these lines here and just change the geom to from density to histogram. We will run that. We will keep alpha as such to see the overlap, but you can see here that histograms are not properly visible. We can change the alpha, and we'll see whether those are getting properly visible or not, but still resolution is not there. Okay. To get this resolution, that histogram is not good for comparison. Now we'll try a bivariate plots here, like box plot. I will put that bivariate plot name here, and will require the categorical value also as x-axis. The students I will use here as x-axis, and this fill is not required because students will separate that. We'll keep it as such, but I will put here instead of box plot, instead of histogram, box plot, and we'll run that. And you can see that this fill is actually redundant here, and it is occupying space, and because of that these names are getting overlapped, and these names are getting overlapped not in histogram and not here also, because those x-axis was not the categorical variable. X-axis was categorical variable only in the box plot now, and therefore the names are getting overlapped. We will resolve that little later. We'll customize that little later. Now we'll remove this fill because it's not required. You'll see that. And this is, we can compare the distributions very clearly as box plot if number of categories is more. Overlapping density plot and overlapping histograms are not suitable to do that. Other alternatives are there, but again there also that comparison is little difficult. I will show you using the facet trap layer, facet trap, and we will facet that using this students, and we'll run that to see those plots get separated into different density plots. We can customize this density also by making scales in histogram. That scales is not argument. We have to make that argument here in facet trap. Scales is equal to free, and then these densities will get properly error. Yeah, comma, I forgot that comma here. Instead of comma, m got typed. Run that, and here you will see 13 different plot panels where those densities are there, but still this comparison is not properly visible here. That separation, when we zoom that, those plots will be visible. You can see distribution of those readings, and here Srushti's readings are quite good as compared to this one, but this scale free is making this comparison little difficult. We'll remove that, scales free, and when we run that, we'll again zoom that out, let it appear, let it get rendered, and here you can see that Srushti's readings are quite narrow here as compared to Shubham's readings, Shravani's readings, and all those. Shubham's readings and Shravani's readings are quite spread out, and similar trends are being seen here. But this comparison, the box plot comparison, is little better as compared to these density plots. Okay, this is my opinion. You can have your own choice also. Now we want to make this box plot little attractive, therefore plus will play with this theme. I will just change that theme to theme black and white. It will look more good as compared to this gray background. On the gray background, colors are more visible, but we don't have colors. Therefore this plot, box plot, is quite good box plot. Now we will play with this axis labels, and this shall be axis tick labels or axis text, which shall be at angle to avoid overlap. And for that we will have to use the theme function again, theme, and inside that we have to play with axis dot text dot x. If you want to play with both axes, then axis dot text is sufficient. But if you want to specify that x-axis, axis dot text dot x will be there. Now we will play with the element text. Many different elements are there. We want to play with element text, and there we will have the angle is equal to 45, and run that. but still this is not satisfactory. We have to adjust the horizontal adjustment, that is adjust is equal to 1, and this is how we got the proper box plot now, which can be published. This axis labels also we can play with using the labs argument plus labs, and that x, I don't want the label there because these names are student names, it's perfectly visible. Then the y axis I want to be volume in ml, and all that shall be in inverted quote. I will put the inverted quote, and this mistyped curly bracket I will remove and run that. You can have title here, you can have subtitle here, all that you can do with the plot to make it publication ready. Now, this plot is visual representation, but statistical tests are also required, and those statistical tests are quite easy to use. But I will show you how to get this box plot using base R function, that base R box plot, and that's also quite easy because here we can use the formula interface box plot, and that volume, I will copy this volume, will be determined by students, and this data is coming from learnng. This formula interface we can use to get box plot, and box plot is there. But here to get the labels correctly, we have to play a little. Just I will put there LAS is equal to 2, and we will run that, and you can see those labels are there, and that x-axis label is actually overlapping here. I will just remove that x-axis label. xlab is equal to just inverted quote, though no x label will be there. Okay. We can play with these margins and all those things so that axis dot cx, here I shall put comma, axis dot cx is equal to 0.7 I will give to make this axis labels little smaller, so that they get this one, this is not happening. Cx is equal to 0.7 I will use, and cx dot axis. At this time I'm not recollecting how to play with it, therefore I will use the plot function, help of the plot function, and generic plot xy plotting, and here that cx and all that arguments we may have. That cx is not there, we may have to Google that to find out how to adjust this axis text. I will just remove that, we will not do that at this time. And this is how we get a good box plot. Now, this I want to use statistical test to compare these different groups, statistical test, and that test is ANOVA. And for ANOVA, we need to ensure that the data is normally distributed and no variance is there. All those assumptions need to be tested, but here in this video I will not test those assumptions. I will just implement ANOVA here, AOV, and in that again this formula interface I will bring there in picture, put that here and run that. The ANOVA got implemented, analysis of variance. Summary will give me the output of this ANOVA, run that. Summary, spelling mistake is there, run that, and here you can see that p value is 0.235. This says that there is no statistical significant difference between the readings taken by student, and that also significant because our alpha 0.05, this value 0.235 is quite large as compared to the alpha. We don't have sufficient proof to reject that null hypothesis. We have to accept the null hypothesis that there is no difference between the readings taken by the students. But if you want to have pairwise, then we can have 2K's HST, and 2K's HST is a post hoc test, and it takes argument that ANOVA model here, and when we run that, we can have these pairwise differences. And if you go through these differences, all the p-values are near n, near 1, because there is no difference, statistically significant difference between the readings taken by the students, pairs of students. Just only one pair is having statistically significant difference, and that pair is also that student who has taken quite wayward readings here. These two students' readings, if we compare Shravani and Shubham, their readings, Shubham's readings are on upper side and Shravani's readings are towards the lower side. And for that reason, these two pairs are statistically significantly different. And there is no difference in all other pairs. We can have compact letter display also in this case, but in this video I will not show that. I have explained that in my another video. Keep on practicing data visualization. And if you have liked this video, please click like button. If you have not subscribed to my channel, please subscribe to my channel, and please click the notification icon so that you will get notifications of my new videos whenever I upload those. Thanks for watching my videos.